Welcome back to this next section of your notes. Um, I'm going to cover 7.2 of your notes. Maybe refer all of us to 7.2 of your notes. I'm going to cover this section of method of differences. Before I illustrate using an example, I just want to say that this method relies on differences between the terms to cancel out majority of the terms. It simplifies a lot of things. Um, in order for this technique to work, you must express whatever is your summation. The summation actually means whatever is your summation as a difference of often 2 or 3 terms. So I'm going to illustrate using an example now. Let's take a look at example 7. There are 2 parts to it. First, they want us to verify this equals to this. I shall not go through very much in detail, but because this one is simple, you just express the 2 as a common denominator. All right, express as common with common denominator. I don't think this is difficult. I will assume that all of us can do this algebra. You just verify. Now, what is this method all about? It is about using this idea. If you notice, this expression here looks very much like this. I repeat, it looks very much like this. The only difference now, this one has r, r, r. This one is n, n, n. So if this one with the n is actually can be expressed as a difference between 2 terms, then I can easily express this as a difference between 2 terms. Remember what I said earlier about method of differences? All right, relying on differences between terms to cancel out majority of terms. All right, and the summation must have contain a difference between 2 terms. So now we have a chance to express this summation, all right, so whatever is in the summation, as a difference between 2 terms. So let us do it here. All right, here. Let's do it here. Instead of r, correct, you just change to n. So therefore, it's 1 over r. Sorry, instead of this one, you all change all the n to r. R square minus 1 over r plus 1 whole thing square. Yes? Now, please pay very, very close attention, not just in the principle, but also in my presentation next. So this part is the easy part. The next part is this. In order for this method to work, you must list out the terms. I repeat, you must list the terms. List out the terms. Meaning this, I sub r equals to 1 into this, I'll get 1 over 1 square minus 1 over 2 square. Now, when I list it out, I do not evaluate. You list out with the terms like that. Do not evaluate. That is when I substitute r equals to 1. For this method to work also, the presentation is key. For each value of r, I will have a line. For each value of r, I have a line. So r equals to, I write another line. That means I substitute r equals to 2 into this expression. R equals to 2 here, 1, there you get 1 over 2 square minus 1 over 3 square. Of course, you will carry on. Write first 3 lines. Write and last, and write the last, hopefully last 3 lines. This will take some practice how to write the last 3 lines, but I'll very quickly write for all of us here. Okay, this is when r equals to n minus 2, r equals to n minus 1, this r equals to n. Now, here is important. I want to emphasize a few things. You I apologize for the lousy handwriting, but important is you every line, a value of r, you want write 1 line. Right, the first three lines, right, the last three lines. Now the killer move is here now. If you write it properly, you will realize that this term, 1 over 2 square and 1 over 2 square, is a minus, a plus, and now is 0. This minus and a plus, and now is 0. And you can anticipate this for, even though you don't have a 1 over 4 square written, it will surely be that. Cancel. Right? This one will cancel the term above, this one will cancel the term above, this one will cancel with the n square. What you are left with is this term and this term. The rest all cancels. Now I want to say that in order for this method to work, this difference between the two summon must actually look rather similar. The moment you have a difference between two expression, two terms that are not so similar, you can't do cancellation. There's no way in the world you're going to do cancellation. But because this is r squared and this is r plus 1 square, you suspect that your method of difference work, and indeed it works. So the final answer will just be your 1 minus 1 over n plus 1 whole thing squared. That is your final answer, which is the same in yours. So this example clearly illustrates how do we use method of differences. I repeat, this is the essence of method of difference. You rely on the differences between two terms to cancel out the majority of terms, right? And it must, of course, the summon must be expressed in as a difference of 2 or 3 terms. So far, we've only seen 2 terms. In later examples, maybe we'll see 3 terms. You do a short quiz and we'll carry on.